సో హలో ఫ్రెండ్స్, వెల్కమ్ టు సైన్ టెక్నికల్ హబ్. సో మనం ఫ్లూయిడ్ మెకానిక్స్ క్లాస్ 2 ప్రీవియస్ క్లాస్ ఎవరైనా చూడనట్లయితే డిస్క్రిప్షన్ లింక్లో ఉంది, వెళ్ళి చూడండి. అలాగే మెటీరియల్స్ కోసం టెలిగ్రామ్ ఛానల్లో జాయిన్ అవ్వండి. మిగతా క్లాసెస్ కోసం స్ట్రెంగ్త్ ఆఫ్ మెటీరియల్, సర్వేయింగ్, అలాగే రీజనింగ్ క్లాసెస్ ఆల్రెడీ స్టార్ట్ అయినాయి. అవి కూడా డిస్క్రిప్షన్లో లింక్ ఉన్నాయి, వెళ్ళి చూడండి. సో పార్ట్ 2 అయితే స్టార్ట్ చేద్దాం.
The next topic is types of fluids. Ideal fluid. When a fluid is called ideal, it is incompressible and having no viscous. No viscous means frictionless. Frictionless. Okay, frictionless. No viscous. It is not exist in real life. Okay, these are imaginary fluids. Ideal fluids are real fluids. It possesses viscosity. They have viscosity. All fluids in practice are called as real fluids only. Newtonian fluids. The Newton's law of viscosity obeys a fluid obeys Newton's law of viscosity is called as Newtonian fluid. Does not obey the Newton's law of viscosity is called as non-Newtonian fluid. In other words, the same thing here also discussed. What means tau is proportional to rate of shear strain is called as Newtonian fluid. If it is not proportional, it is called as non-Newtonian fluid. Non-Newtonian fluid. If the shear stress is more than yield value, that is yield stress, yield value, shear stress is more than yield value, then it is called as ideal plastic fluid. Okay, sorry, ideal types of fluids. It is ideal fluid, that means no shear stress, tau is 0. Newtonian fluid, tau is directly proportional to du by dy. Non-Newtonian fluids, tau does not proportional to du by dy. The curve above Newtonian fluid and the curve below Newtonian fluid also called as non-Newtonian fluid only. The curve above Newtonian fluid is called as pseudoplastic. The curve below Newtonian fluid is called as dilatancy. Okay, if tau value is greater than yield value, then it's called as ideal plastic fluid. Types of fluid is over. The next topic is compressibility and bulk density. Bulk density is defined as the ratio of compressive stress to volumetric strain. Volumetric strain is change in volume by original volume. Compressive, that is, it is a block. This is force applied. The stress due to that compressive load is called as compressive stress. It is the ratio of compressive stress to the volumetric strain. It is denoted by letter K. I given an example for this. For the formula, take initially it is closed. The position of this is here 1. The place of 1 is changed to place 2, then the volume will decreases. So the volume will decreases, pressure in this case is increases. Pressure in this case is increases. Air pressure in this case is increases. A volume will decreases. So the negative sign refers to the pressure increases with volume decrease, or volume decreases with increase of pressure. The unit of bulk modulus is Newton per meter square. In dimensions, Newton ml t power minus 2 divided by L square. That is, dimensions are m, L power minus 1, t power minus 2 is the dimensions for bulk density. Compressibility, it is compressibility beta, for example, compressibility beta unte it is a reciprocal of bulk density. The units are also reversing. So the SI unit will be meter square per Newton. The dimensions are m power minus 1, L t power minus 2. The next topic is surface tension. It is defined as the tensile force acting on the surface of liquid in contact with gas. If it is a liquid surface, it contact with air, or the liquid surface is a contact with another liquid surface. In both cases 1 and 2, a thin membrane is forming. This is due to surface tension. Best example for surface tension is mosquitoes on water surface. This is mosquito. Let's say this is mosquito. This is water surface. It cannot immerse in water. It is stand on water surface. This is due to surface tension. It is denoted by the letter sigma. The unit will be kgf per meter. This is MKS unit. In SI unit, Newton per meter. The dimensions for Newton ml t power minus 2 divided by L get cancelled. M L power 0 t power minus 2 is the dimensions for surface tension. And surface tension on liquid droplet. P refers to pressure intensity inside the droplet. Sigma is surface tension. D is the diameter of the droplet. P is equals to 4 sigma by D. How it get? Pressure force equating pressure force with force due to surface tension. Okay. Please remember these formulas for your problematic, for numericals to solve. Surface tension on a hollow bubble like soap bubble. Both in outside also it is contact with the air, and the inside also it is contact with the air. What the surface tension definition says: water or air, contact between water and air are two immiscible liquids. Contact, there is a thin layer forming due to tension. Okay, so it is 2 times of surface tension due to droplet. Okay, surface tension on a liquid jet is P is equal to delta by D. It is like bar. This is L, this is D. The next topic is capillarity. Capillarity is defined as the phenomenon of rise or fall of a liquid surface in a small tube relative to the adjacent general level of liquid when the tube is held vertically in the liquid. This is, for example, in this liquid is present. Capillary tube I insert in vertical. If the water rises in the capillary tube, it is called as capillary rise. If the water is held in vertical in the tank, the water is the fluid in the capillary tube is falling, it is called as capillary depression or capillary fall. It is expressed in terms of centimeter or millimeter of liquid. Dimensions are L only, so m naught L to power 0. Expression for capillary rise or fall. The same formula, H is equals to 4 sigma cos theta by rho GD. Rho gamma is equals to rho G. So in place rho G you put gamma, 4 sigma cos theta by gamma D. In capillary rise condition, theta will be approximately 0, so the cos theta will be 1. So the capillary rise formula is equals to H is equals to 4 sigma rho GD, that is 4 sigma by gamma D. The value for theta for mercury and class is 120 degrees, approximately 130 degrees. Approximately 130 degrees. Summary. Fluid in the capillary tube is water tends to capillary rise. The theta value will be approximately 0. Water more addition. Okay, where in case of mercury, Hg, mercury in capillary tube, more cohesion, the theta will be 130 degrees or 18 theta will be approximately 130 degrees. Capillary depression or capillary fall. The next topic is vapor pressure. Consider a liquid which confined in a closed vessel. Take this is a vessel. Let's say this is vessel closed. It is closed. Water is present in this closed vessel, this closed vessel, this closed vessel. The temperature initially the temperature is 20 degrees Celsius and the pressure is atmospheric pressure. It is heating up. The liquid will vaporize at 100 degrees Celsius. At 100 degrees Celsius, vaporization takes place. Molecules escape from the free surface of the liquid. It is closed. These are vaporized and accumulated at the free surface. These vapor molecules get accumulated in the space between the free liquid surface. This is a free liquid surface and the top of the vessel. This is the top of the vessel. These accumulated vapors exert a pressure on the liquid surface. These vapors exert a pressure on this liquid. This pressure is called as vapor pressure of that liquid. That pressure is called a pressure at which liquid is converted into vapors. Is called as vapor pressure. I hope this understand clear. It's clear. The next topic is cavitation. Consider a flowing liquid in a system. If the pressure at any point in this flowing liquid becomes equal to or less than, you consider less than or equals to, may be equal, might be equal, but it is less than vapor pressure. Okay, the vaporization of the liquid starts. For example, I take a river. Here the pressure is less than or equals to vapor pressure. Okay, vapor pressure. The bubbles of these vapors are carried by the flowing liquid into the region of high pressure where they collapse, giving rise to high impact pressure. The pressure developed by the collapsing bubbles is so high that the material from the adjoining boundaries gets eroded and cavities are formed on them. This phenomenon is known as cavitation. ఈ విధంగా ఉన్నప్పుడు బబుల్స్ అనేటివి ఫామ్ అవుతాయి. వేపర్ బబుల్స్ అవి హై ప్రెషర్ రీజన్స్కి వెళ్ళినప్పుడు కొలాప్స్ అయిపోతాయి. ఆ కొలాప్స్ అవ్వడం వల్ల ఏం అవుతుందంటే అక్కడుండే ఫర్ ఎగ్జాంపుల్ సాయిల్ అనుకుంటే ఆ సాయిల్ అనేది ఎరోడ్ అయిపోతుంది. అక్కడ పిట్స్ లాగా తయారవుతుంది అనమాట. ఆ పిట్స్ తయారవుతున్నాయి కదా, అవి వాటిని క్యావిటీస్ అంటారు. ద ప్రాసెస్ని ఏమంటారంటే క్యావిటేషన్ అంటారు. I hope this is understand. In the next class we discuss problems. Thank you.